So the 67 question is in a group Z11 additive modulo 11 and multiplicative modulo 11, the solution of x multiplicative modulo 11 5 bar is equal to 4 bar. So what value of x this condition will be satisfied? He is asking the value of x here. So for this we have to, by using the option verification, we can say that suppose if I take the value x as a 6, so I will get 6 y is a 30. So if you do the multiplicative modulo with respect to 11, we will get that 11 to the 22. So that remainder, we whenever this modulo will there, we have to write the remainder here. So you will get that 8 here. So it is not satisfying the, it is not come to the 4 bar. So we can discard this one. This is not satisfying the given condition. So again I can take 8 in place of x. So I can get 8 5 is 45. So if I take that one, 8 5 is 40. So if I take that one with 11 as the modulo 11, so I will get that 11 3 is 33. So I will get 7 here, 7 here. So which is also not satisfying. We get 7 bar here. So here 4 bar is there. So if I take 3 here, so 3 5 is 15. 15. So under modulo multiplicative modulo 11, if I do 11 ones are 11, so I can get 4 bar here. So that's why the 3 is the correct value of x. So we can say that option 3 is a correct one by proving like this way, simple one. So 68th one is the inverse of element. He provided one matrix, that is A is equal to 5 3 2 4, and in a group GLNR, general linear group, and order 2 cross 2 matrices are there under modulo Z13. So he is asking the inverse of these matrix. So what can we do? We can just first of all find the inverse of these given matrix. Then we have to apply the modulo 13. Then we can get the inverse of that given matrix. So the inverse of these given matrix is whenever 2 cross 2 matrix is there. Suppose A, B, C, D. So whenever these type of A, B, C, D matrix is there, so the inverse should be, we can find out. So 1 by, suppose if I call it as a, so that will give you determinant of A into the value should be D A minus B minus C minus C. So this is the inverse of 2 cross 2 matrix. We know that is a basic thing. So similarly, in place of ABCD, we have that this matrix. So if you do that one, you will get determinant of A should be 5 4 the 20 minus 6 minus 6. So we get that 1 by 14 into, so D value is, we get that 4, and similarly A value is 5, and C value is remaining same, but we multiply with minus 2, and B value should be 3 here, so that is minus 3. So now you have to apply, so now you have to apply the modulo 13. If you apply the modulo 13, here 14 is there, so the remainder we will get only 1, so that is 1, and here 4 is as this, but here minus 3 is there. If you apply the modulo 13, so you will get that 10. So you just remove taking the negative subtraction from the 13. So if you remove if you subtract the 3 from the 13, you will get that 10. So 10 as a remainder. So similarly, if you do minus 2, you will get that 11, and for 5 no need to change because there is no negative terms. So if you multiply this one, so you can get simply 4 10 11 and 5. So this is the inverse of the given matrix. So second option is correct for this one. And 69th one is, if pi z10 to z20 is a homomorphism such that pi of 1 equal to 8, then what is the value of pi of 2? So he already provided that is a homomorphism. So he provided one condition, that is pi of 1 equal to 8. So I just randomly choosing the pi value, that is suppose if pi of x is equal to 8x, if I take like this way, then I am just going to checking whether it is satisfied or not. So if I take value of x should be 1, so that will give you pi of 1 is equal to we can clearly say that this is a homomorphism. So that will give you 8 into 1 is equal to 8. So we can say that this is satisfying the condition. Pi of x equal to 8x will satisfy the one condition. So by applying that in place of x, we just replace by 2. You will get that pi of 2 into is equal to 8 into 2. So that will give you 16. So that is the value is asking pi of 2. So we will get 16 here. So the third option is correct one for this 69 question. So the 70 question is the set of even permutations. We know that set of even permutations is an in symmetric group Sn. So he is asking the set of even permutations in a symmetric group of Sn. So we know that that is a normal subgroup of Sn. So that is a direct one. We can say that alternative groups are normal subgroup of a symmetric group Sn or permutations group Sn. So the 71 question is the order of the permutation alpha is equal to cycle 132 567 268. So whenever these cycles are, whenever he is asking the order, I already told that whenever these cycles are distinct means we can directly use by we can directly do it by using the formula. So order of alpha is, suppose you have two cycles A and B, alpha is equal to A and B, alpha is equal to A cycle and B cycles. So it contains cycles. I am not saying that are elements. So the order of alpha is, we can say that order of A, LCM of order of A into comma order of B. So that is the formula for whenever these type of distinct cycles are there. So but if you observe carefully, here 6 is there and 6 is there, 1 is there, 1 is there. So from this we can say that these three cycles are not distinct. So we cannot apply this formula. So what we do, we just multiply these two cycles, we will get the distinct cycles, then we can apply the formula. So what I do, I just simply multiply these first two cycles. So I will get it by using the, we know that how to multiply two cycles. By using that one, we will get it. First here 6 is common, so I will just multiply this 2 and 3 cycle. So I can write I can return these two. First cycle will be as it is. I am just multiplying these two remaining two cycles. So I will get, that is 2 goes to 6 and 6 goes to 1, 6 goes to 7. So I can return as the, if you multiply that one, you will get 2, 7, 5, 5, 6, 1. So if I multiply that two cycles, I will get like this way. And again, if I multiply these two cycles, so I can get 2, 7 by using the way of how to multiply two cycles. So we will get like this way, 5, 6, and 3. So we can get 3 one cycle and it contains 5 elements. So that's why the order of alpha is 5 here. So we are not going to use this formula, but whenever distinct cycles will be arrived in examinations, you just use this formula. But here we no need, because we have only one cycle, there is no distinct cycles are there, so we are not going to use that formula. So I just do it by multiplying the two cycles, so I can get it. So the 72 question is number of generators of a cyclic group of order 15. So I already told you, whenever generators of a cyclic group or abelian group question will come, you just simply do it. When in general, whenever generators of cyclic group of order n means, we can use the formula pi of n. So here he is asking the 15. So we can written as pi of 16. So if you simplify this one, you can get the number, how many generators are there. So that pi of 15, if I simplify that one, so I can get it pi of 15, I can written as a pi into 7, 3 into 5. So that will give you pi of 3 into pi of 5. So if you simplify that one, you will get pi of 3 means 2 and pi of 5 means 4. So that will give you 8. So the answer is 8. Option 4 is correct one for this 72 question. And 73 is So which one of the following statement is true? So here he is asking the true statement. You should be careful about that one, whether he is asking the true or false. So the set M2 of Z 2 cross 2 matrix with integer entries is a commutative ring. No, the we know that whenever two matrices are there, it never be commuted. So this option will be false. You just discard that one. And second option is 2Z union 3Z is a subring of ring Z. No, it may not be happen, because I will tell you, whenever if you union these 2Z union 3Z, so you will get the elements of inside of these subgroup, that is 2, 3 and 6. Like this way the elements are there inside of this union of two subgroups. So that will give you, suppose it should be satisfying the, he is mentioned that ring. So here we have to check whether it is satisfying the closure property under addition. So if I take two elements 2 and 3, if I do the close, if I apply the closure property, I will get 2 plus 3, so that will give you 5, but it should not be contained inside of ring R. So it is failed the closure property. Then we can say that it is not a sub ring of a ring Z. So it should be not a subring of Z. So the option 2 also we can discard. So every integral domain is a field. So we can clearly say that by using this one, it is a single correct option. So whether this one are correct, this one are correct. So the converse will be satisfying, but these part will never be satisfied. Every integral domain is not a field, but every field is a integral domain. That is the direct statement. So we can say that this option will be wrong answer. So the 74th question. So here the every field is integral domain means every ring contain, every ring is commutative with unity. So it is satisfying the field. Every non-zero element has a multiplicative inverse. So if every element satisfying that condition means, then we can say that clearly it is an integral domain. So that's why this condition is satisfying. So for 74th question, which one of the following is the idempotent element of the ring? So we know that, see, he asking about idempotent element. So when we say that idempotent element of a ring, so suppose there is a element from a ring R. So if I take that element from a ring R, so when we say that this element A is a idempotent element, so that should be satisfying the condition for A square equal to A for every A belongs to G. So that will give you, if it is satisfy these conditions, then we can say that the element A is idempotent element of a this ring, given ring. So similarly, he is asking the idempotent element of a Z10. So you just do that same thing, 8 square, that will give you 64. So if you 64, if you do that under the multiplicative modulo of 10, so you will get 4. So that will never be satisfied. So you can discard this option. Similarly, you can do 3 square, that will give you 3, that will give you 9. So if you do under multiplicative modulo of 10, so you will get again 9 or minus 1. So that is also not satisfying. So if you take the option 3, that is 4 square is equal to 16. So by using the multiplicative modulo 10, so you will get that 6. So it is also not satisfying. But if you take that 5, so you can do that 5 square is equal to 25. So by applying these multiplicative modulo 10, so you will get that 5 as a answer. So 5, if you are start with 5 square and you get that 5, so it is clearly satisfying with A square is equal to A. So then we can say that 5 is the idempotent element of it, the given ring. So here 5 is the correct option for this question. And two zero divisors in Z9 is Z9 ring. So he's asking the two zero divisors of a Z9 ring. So when we say that the two elements are a zero divisor, suppose if I take a two elements from a ring, suppose I am just taking two elements, if I do the operation, binary operation, so it will gives you 0, but these two elements are never be 0. Either A is equal to A is not 0 or B is not 0. Then we can say that these two elements are 0 divisors. So similarly, if you take these two elements, it will give you 14. But if you apply this 9, under multiplicative modulo, you will get that 5. So it is not going to 0. So just this option is wrong one. And if you take 6 and 3, so I will come later for this option. I just discard the all option first. So if you multiply with 1 into 8, so you will get 8. If you apply the multiplicative modulo 9, so you never get 0. So this is also not correct one. So if you take 4 into 5, you will get 20. So if you apply these modulo 9, so you never get 0 here. So this option is also wrong. So the remaining only option 2 is left. So we can say that this option is correct. So I can do that one also. If you multiply 6 into 3, 6 into 3, so that will give you 18. So we know that under by using the modulo 9, we can say that this will goes to 0. So there are two non-zero elements, it will give you a 0. So by using these general condition, we can say that these 6 and 3 are the zero divisors of the given ring Z name. So that is the correct. Second one is the correct option for that question. And 76th one. So if you observe carefully, here he is asking the characteristic of a Boolean ring. So I already discussed this question. It is repeating question in this 2023. It is already there in 2021. So this, I already told you in that video also. So that is when we say that characteristic of E is asking the Boolean ring. Boolean ring means first of all the set the ring contain all the elements are idempotent elements. So the ring contain all elements are idempotent elements. We already discussed that idempotent element means A square will be A. So for every A belongs to R, then we can say that that is a Boolean ring, and every element of inside of that Boolean ring is satisfying the idempotent conditions. Then we can say that ring has a Boolean ring. So we know that if you take the Z2 randomly, it contains two elements 0 and 1, and it should be satisfying the condition 0 square equal to 0 and 1 square equal to 1. So the characteristic of these rings should be 2. So similarly, if you take whatever the ring you want, you just take the Boolean ring. So the characteristic of that ring should be goes to 2. So the option 3 is the correct one for this 76th question. The 77th one, if function z into I to the z defined by f into a plus ib is equal to a for all a plus ib. So he is asking whether it is homogeneous or homomorphism or not a homomorphism and isomorphism or one. He provided these type of conditions. So we have to check which one is correct one. So whether it is homomorphism or not. So here we can observe that carefully. Homomorphism is there, not homomorphism is there. So whenever these type of two options are there, you can sure that whether the option is in between one or two. Okay, so the remaining options are wrong. So you can directly discard these type of options because these exam is contain only single correct option. So he is saying that it is happened and this is not happened. So if it is happened means this is not happened. If it is not happened means it is happened. So the answer should be in between option 1 and 2. So you can directly discard that option 3 and 4. You need no need to check it. So we will check it whether it is homomorphism or not. So we know that in general, when we say that that is a homomorphism, suppose if I take the two elements from a ring R, so if it is satisfying these type of condition, so the ring is satisfying these function. So with some binary operation, we don't know whether that binary is additive or multiplicative. So it should be satisfying these condition f of a star f of b. So then we can say that f is a homomorphism. If it is satisfying, he is saying that ring. He provided the ring here. So not a ring. He is not saying the ring. So if it is ring means we should check both because in a ring we contain the two operations additive. Suppose if I take ring as a R, we have to check for both additive and multiplicative. We can say that that is a homomorphism or not. But group we have only one, whether it is addition or multiplication, whatever it is, whatever the binary operation. If it is satisfied these conditions, then we can say that f is a homomorphism. So he provided already one function. So by using this one, I can written as a1. He already provided b also. So I am just using a1 b1 form. So I will get like this way. I am just taking the 2 as this. So a star, it will give you a2 plus I b2. So that will give you, it will get a, means the first term will get it. So we get A and A2. So that will give you A1 into A2. So it will never be equal to f of A1 I B1 star f of A2 I B2. So I B2. It never be satisfied. These two conditions are never be satisfied because we get A1 and A2. So we cannot write in the form of this form. So it never be happened. So we can say that it is not satisfying these given above condition. So we can say that this is the given function is not a homomorphism. So the second option is correct one for this question. So just remember, whenever these type of options will come, you just make sure that the option is in between option 1 or option 2. So in that time you can directly discard the option 3 and option 4. Okay, because this exam I already told you, this exam is only single term, single option correct one. So if it is MSQ means you cannot say directly whether it is satisfying or not. Okay, so that is the logic here. You just use that one, you can simply get the answer. So the 78th one is number of ideals in a field. We know that in a field, every field contains the ideals are only two ideals, that are the trivial ideals. Trivial ideals, we can say that singleton 0 and the whole ring R. So that are the two ideals in every ring. So in a field, so the number of ideals in a field, so in every field of a ring contain only two ideals, that are identity and whole ring R. So we can say that only two ideals are there in every ring of a field. Suppose a ring is a field, then we can say that the number of ideals are two ideals. Okay, so if it is not a ring, if it is not a field means we cannot say more than two also present inside of that ring. So the 79th question is, an ideal M of a commutative ring R with unity is a maximal ideal if R by M is. So this statement is direct statement and important statement. Whenever these cases happen, if and only if statement, this is whenever the R with unity is maximal ideal, then we can say that R by M is a field. So I will give you another one. This is a direct statement, and another important statement is also there. Whenever R by I is a principal ideal, here maximal ideal there, whenever these cases a prime ideal, whenever R by I is the prime ideal, if and only if I is the integral domain. This is also very important one. Integral domain, integral domain. So this statement is also important. Just remember these two are direct statements. So if you remember that one, you can directly get it. 79 option. And 81 is, if F is a homomorphism from a ring R into a ring S, then R by kernel of is isomorphic to which group? He is asking what we get it. So he already provided R and S and image of F and R by image of F. If you remembering directly the first fundamental theorem of isomorphism, every group divided by kernel of that F is isomorphic to the image of G. So this is the direct one, the first fundamental theorem of isomorphism. So by using that, we can directly say that it will be image of F. So we can say that the third option is the correct one for these type of questions. We already provided that F is homomorphism from a ring R to R. So in group also, ring also, that will same that first fundamental of isomorphism theorem. So the 81 question is, every subset of linearly independent set is independent. Yeah, that is the correct one, because if you take the set of linear independent set, so whatever the elements you are taking inside of that linearly independent set, always you can get linearly independent only. So that's why we can say that this is a linearly independent. So the 82 one is, W1 W2 are the two sub-bases of a finite dimensional vector V of F. Then dimension of W1 and W2. This is also direct statement. So you can say that dimension of W1 plus W2 minus W1, W1 intersection W2. So I can remember it by using the probability. We know that in our type 10th and 9th classes we have that P of A union B, we have the formula. I am just remembering these one by using these three. So you also, you want, you can remember like this way. So w1 plus w2 means union, we get the all the vector space. So by applying that one, we can get p of a into p of b minus p of a intersection b. Okay, so by using these one, I'm just remembering, if I forget sometime, I just remembering by using these one. So if you want, you can use this trick also, you just remembering that one. The proof is not a simple, you should remember these type of one, because in competitive exam that will give you reduce the time to solve. So 83 one is, if t is a linear transformation which is from r to the power of 6 to r to the power of 6, such that rank of t is 4, then the nullity of t, this is a simple one. We know that by rank nullity theorem. So that is a direct statement. By rank nullity theorem, we can say that rank of t plus nullity of t is equal to r to the power of 6. So dimension of r to the power of 6. So by using that, we know that he already provided rank 4, plus he is asking the nullity of t. Okay, he is asking the nullity of t. Dimension of r to the power of 6 is 6. We get it, nullity of t is 6 minus 4. So from that we can get that n of t is equal to 2. So the nullity of t should be 2. The third option is correct one. If you just remembering that statement of rank nullity theorem, you directly get the answer 2. So 83 is the correct option. 83 is, as a third option is the correct one. So 84th one is, if a linear transformation t from r cube to r square, then defined by t of a comma b comma c is equal to a plus b plus c comma a minus b minus c, then the element of in the null space of t is, so he is asking the null space. So when we say that that space is a null space, suppose if you have the space like this way, x comma y comma z. So if you apply one vector, you should get 0 comma 0 form. So we don't know, I am just taking r square because he provided r cube to r square. So whatever space it is, r power n, you just consider like that way. But we, in question is asking r cube to r square, that's why I'm taking the case. So whatever the value of x and y and z, if it is satisfying these type of conditions, then we can say that that set as a null space of a element of t. Okay, so by using that one, we just doing the option verification, we will get the answer. He already provided the transformation of this one. I am just substituting, we can consider as a b c here and check one by one which one will satisfy the 0 by 0 comma 0 form, then that set is an element of in the null space of t. Okay, first option I am taking 1 minus 1 0. If I take 1 minus 1 0 here, so it will goes to 0, fine. But here there is a problem, it will give you 2. So 0 comma 2, we will get 0 comma 2. So it will be not equal to the 0 comma 0. So this option will not satisfy. So this is a simple trick. By using the option verification, you can directly say that, no need to go through any method. So that second one is, I am just checking second one whether it is satisfying the that condition or not. So I am taking a b c as this one, I am just substituting this one. I will get 1 plus 1, first one is 0, a value, that will give you 1 minus 1 minus 1, so that will give you 2 comma minus 2. This is also not satisfying. Second option is also, we can cancel it. So if you get 0 comma 0, then only we can say that that space is an element in the null space of t. So if I taking the third option and taking these vector consider as a b c, you can clearly see that it should be satisfying. So if I take 0 a in place of a 0 and in place of b as a 1 and in place of c as a minus 1, so I can get that 0 minus 1 minus 1, here minus 1 is there, minus c is there, here minus 1 is there, so that will goes to plus 1. So you can simply get it as here minus 1 minus 1, so that will give you minus 0, and here plus 1 minus 1, so it will give you 0. So it is satisfying the given that condition, 0 comma 0 condition. Then we can say that this 0 1 minus 1 is there an element in the null space of a t. So we can directly say that by using the short trick, this is the one method. Even if he is asking the rank or null space, if it is rank means it should be produce a whole space, so there is no negative terms will present here, then we can say that the rank of t. So okay, so by using these simple trick we can say that directly. So the third option is the correct one for this question. And 85, 85 question, t r square to r square is defined by t x comma y is equal to 4x minus 2y 2x plus y, then the matrix of t. So he's asking the matrix and he provided one linear transformation here. So by using that one, he already given that the reason linear transformation is r square to r square, and he provided that basis also. By using those bases we can say that, suppose if I take the basis 1 1 comma 0, if I substitute here I can get it, I can get the value in place of x you just substitute 1, and in place of y you can substitute 0. You can get that 4 comma 2. And similarly, if you consider these bases 0 comma 1, substitute in that given linear transformation, you will get that 0 comma 1 is equal to, so that will give you, in place of x we are replacing 0 in this time, and in place of y we are replacing by 1. So we get that minus 2 comma, so here 1. So by using these two vectors value, we can write it by using the standard basis method. We can written as in the form of, suppose we have a matrix A. So by using the basis B, I can written as a in the matrix form, that will give you, you can write in row form. So that will give you 4 comma 2 and minus 2 comma 1. So this is the required matrix he is asking, the matrix of T by applying the these given basis. So we get that 4 2 minus 2 1. So whenever these type of, we already provided basis and he is asking the matrix means, you just simply substitute the values in basis values in the given linear transformation. You get the two vectors, just write in the form of row, not in column. Row you can write in row, and if you want to write in column, you just do the transpose, you directly get the matrix, required matrix of given linear transformation. So the option 2 is the correct one, the other options are wrong for these question. So 86th one is, so if the linear transformation, 86th question is, if the linear transformation from t r cube to r is defined by t, he provided t of 1 comma 1 comma 1 is 3, and t of 0 comma 1 comma minus 2 is 1, and t of 0 comma 0 comma 1 is minus 2. So what is the value of t of x comma y? He is asking the function. So you may you can do by one or two methods. So I will tell you shortcut trick how to proceed whenever these type of questions come. You can do by using matrix form also. So I will tell. So if you just go through this one, so if you take one x value 1, y value 1 and z value 1, just go and take this one as the option first and substitute whether it is satisfying with 3 or not, and take this vector and satisfying 1 or not. So just take it. If it is satisfying the 3 condition, then we can say that this is a linear transformation of a the given r cube to r. Okay, so I am just taking this 111 as xyz, and I can check it whether I get 3 or not. So if I take that t of 1 comma 1 by using these xyz, I take 1 comma 1, so I can check it 8 into 1, 8 into 1, 8 into 1 minus 3 into 1, minus 3 into 1 minus 2 into 1. So if you clearly see that, it will give you 8 minus 3 minus 2. So you can get it as a 3. So the first condition is satisfying. So you can go through the next conditions also, 0 comma 1 comma minus 2. So if you apply same as this by using option verification also, we can say that directly. That only I am doing here. So 8 into 0 and minus 3 into 1 and minus 2 into minus 2. So if you simplify this one, you will get minus 3, 0 minus 3 and minus into minus will goes to plus 4. So that will give you 1. So the second condition is also satisfied. This is 3 first one, and 1 we can get second one. So the third one I can take as t of 0 comma 0 comma 1. Similarly I can substitute in the given option. So that will give you 8 into 0 minus 3 into 0 minus 2 into 1. So that will give you minus 2. So it is satisfying the three conditions. If you check the other options, it never be satisfying the three conditions. So we can discard by using these simple trick. You just remembering these simple trick, you can get it as a option 1 is the correct option for these type of questions. Okay, so that is the simple one. You just remembering that one. So he is asking 87 question is, if t of r cube to r is defined by t of x comma y comma z, so that is x plus y and y plus z, then rank of t. So he is asking the rank of t. Whenever these type of questions come, he is asking the r cube here. So he provided r cube. So the basis of the r cube should be always in the form of standard basis 100. We know that this is a simple one, and 010. These are the standard basis of r cube. If it is n times, means we can return as a n times by using the n tuples. Okay, so by using the tuples we can write here the 3 is only the day. So that's why these three are the standard basis of these linear transformation. You just substitute these three things in this linear transformations, you will get t of 100. So that will give you 1 comma 0. And similarly, if you substitute second one in place of, sorry, t of 100. Okay, so t of 010, so that will give you 1 comma 1. And similarly, if you substitute third one also, so you may get that 0 comma 0 comma 1. So that will give you 0 comma 1. So you just write in the form of matrix. So check it which one you will get. You can write in the form of matrix 1 0, either it is in column or row. So you will get 0 comma, so 1 comma 1 second one. So first one is 1 comma 0, second one is 1 comma 1, and third one is 0 comma 1. So I am just writing in the form of matrix. So that will give 1 comma 1 and 0 comma 1. So if you observe carefully, if you do the row operation, so it will give you this matrix as a 1 0 and 0 0 and 0 1. So there are two linearly independent vectors are there. So then we can say that the rank of these linear transformations should be always 2. Okay, so you have a doubt how to get this 0 comma 0. If you do the row operation r1 minus r2 and r3 minus r2, you can get that 0 by 0 into 0, and you just write in the form of matrix. You can get that the rank as a 2 for these questions. So you just proceed like this way by using the standard basis. So you can simply find the rank of the matrix of the t. So in previous question is also is asking that rank. So you just show that whatever is given in the question, so what do you have to proceed for a solution. Okay, so if we directly provide some more conditions, then we can use some previous question we used the rank nullity theorem to find the rank. Okay, he is asking the by using the linear transformation find the rank. So we just proceed like this way. So by using is whatever he provided in the given question, so by using that condition we can proceed further. Okay, the 88th question is eigenvalue of a given matrix. He provided one matrix and he is asking the eigenvalues. So this is a simple one. How can we find the 2 cross 2 matrix eigenvalue? Lambda square. We can directly write lambda square trace of a. Suppose if I consider matrix A, this is a trace of a plus in lambda plus determinant of a, det of a. So it is equal to 0. So that will give you the characteristic equation. So by applying this simple formula, we can directly find that. We no need to use this a minus lambda. That will also give you that, but it will take a lot of time. If you take like this way also, you can get the eigenvalues, but it will take a lot of time. So the lambda square I can written as same as this minus trace of a. Trace of a will give you, if you add trace of a means the sum of diagonals. So that will give you 1 minus 1, that will give you 0 plus determinant of a. So if you do the determinant for this, so you can get minus 1 and minus 6. So that will give you minus 7. Minus 7 equal to 0. So that will give you minus lambda square minus 7 equal to 0. So that will give you lambda is equal to plus or minus root 7. Root 7. That is the correct option. These are the two eigenvalues of a given matrix. So we can say that first option is a root 7 comma minus root 7. So that is the correct option for these questions. So the 89 one is the eigenvector of a x comma x2 corresponding to the eigenvalue minus 2 of a matrix. He provided one matrix and he is asking about eigenvector. Here he is asking the eigenvectors of a the corresponding eigenvalue minus 2. So how can we proceed for that? So I am just taking the condition first. Whenever these type of finding eigenvector will come, we can return as a v is equal to lambda v. So here the I v is the eigenvector. So by using that I can find directly. So you just take the matrix. We know that this is A. So we just consider this is A, and that is 1, 3, and 1 minus 1. So we get like this way, and I can take directly x1 and x2, x1 and x2, because he is asking in the form of x1 and x2. That's why I'm taking that one. We know that eigenvalue minus 2, minus 2. I am just writing that minus 2 here, and x1, x2. So you can do two methods. If you multiply these two 1 cross 2 matrix and do this one, so you will get one linear equation. So by using that also you can do that. Otherwise you just satisfying one by one in place of one x1 and x2 and check whether these both are equal or not. If it is both are equal, then we can say that that vector is eigenvector. So I prefer that method only because that is very simple to me. So that makes me very simple. So if I take 1 comma minus 1 directly, you can do the option verification. You directly get it whether it is satisfying or not. So I am taking the second option directly. So 1 comma minus 1, that will give you minus 2 into 1 comma 1 minus 1. So if you multiply this one, you will get directly 1 minus 3 and 1 plus 1. So you will get like this way. And if you multiply 2 here, so if you multiply 2 here, you will get minus 2 divide into not divided. So that is, it is in the form of matrix, right? So we have to write 2. So we will get minus 2 comma 2 here. So similarly, if you do that this one also, you will get minus 2 comma 2. So the both are equal. So it is satisfying the eigenvalue eigenvector condition with respect to corresponding eigenvalue minus 2. So we can say that second option is the correct one for these questions. So whenever he is asking about eigenvector, you just proceed by this method. You can simply directly get the answer. So other method also you can do it by multiplying these x1 x2, and you can get that same x1 value is 1 and x2 value is minus 1. So I just directly applied the values of x1 and x2. I get like that way. So the 19th question is, so he already provided two conditions. So he is asking which one is the correct one and which one is the true statement or which one is the false statement. So every superset of a linearly independent set is linearly independent. So that is a false statement. Why? Because if I consider the suppose R cube, so I will give you one counter example why it is wrong. So if I take that one, so I have a vector 1 comma 0 comma 0 and another vector 2 comma 0 comma 0, and another vector I have a 1 comma 0 comma 0 comma 0 comma 1. I have these three vectors. We can say that if I take the subset of these, suppose I consider as a R. So if I take the subset of these R, S is a subset of R. If I consider as a set S, so inside of S contain inside of R. So I am just taking 2 1 0 0 and another one is 0 0 1. So from observing this S is a linearly independent, but this R is not linearly independent because it contains two. One is linearly dependent vector. So he is also saying every superset of linearly independent set is linearly independent. So that is not possible because this is a linearly independent set. That superset will be never be linearly independent. So that is not need not be true. So that's why we can say that the first statement is false. Okay. So the second one is set of n plus 1 vectors in vector space is linearly dependent. Yes, it is linearly dependent because we have only the space is only r power n, but it contains n plus 1 means we can say that there is a one element extra will contain inside of this one. So that element is linearly dependent one because r power n contain only n linearly independent sets. So but he is saying that it contain n plus 1 vector. So then we can simply say that that r power n content is linearly dependent because it contains n plus 1 vectors. So that statement is true because he is saying that linearly dependent. If he is saying that linearly independent means we can say that that statement is also false. So this statement is true. So for that, the second statement is true, means second option is the correct one for these questions. So the 91 question is the characteristic vectors of distinct characteristic roots of a matrix are always linearly independent because they are orthogonal to each other. The functions are, so we can directly say that second option is the correct one. So that is linearly independent. So the 92 question is, so he provided one matrix 3 cross 3 matrix. He is asking about inverse of that characteristic. He provided one characteristic polynomial by using that 3 cross 3 matrix. He is asking the inverse of that matrix. So what I do, I just simply do that one. This is very simple. So if I do that one, a cube minus 3a square 3a square plus 4a. I am just taking these minus 6i as a right hand side. I will get 6i. So what I do, I am just doing taking a as a common because a is there in each term. So I am just taking a common. I will get a square minus 3a plus 4. So that will give you 6i. So I am just multiplying both sides as a universe by multiplying both sides a universe. So I will get this a into a inverse, and I will get extra a universe here. So because I am just multiplying both sides a universe, so this a and a inverse, we know that it is goes to identity. So we no need to write that one, because if you multiply with identity we will get same term. So we will get a universe of minus 3a plus 4 is equal to 6 a universe. I am just taking these 6 as a denominator. I will get a universe equal to 1 by 6 into a square minus 3a plus 4. So in 4 we can write an as identity element also, that is no problem. So we get that fourth option is the correct one. This is a simple one. Just you have to, whenever you the question will come in front of you, just look like what he provided and what he is asking. So in that way we have to go through. So you can another method also you can do it. That is a too long method. That is you have to consider one 3 class matrix, and you have to check it by using these conditions. You have to form a one matrix, and you can find the inverse of that matrix. So that is very big thing. So by using these simple tricks we can do it. So the option 4 is the correct one for these type of question. So the 93 question is 27 comma 46 is equal to a 5 comma 6 plus b 3 comma 7. So he is asking the sum of a plus b. So we don't know what is the a comma b. So for here also we can do it simple. So if he is asking direct a comma b value, we just by option verification we can say that. But he is asking the sum of that a plus b. So what we do for this, we just multiply a with this vector and b with this vector. We get two vectors. So if you simplify that two vectors, you get the values of a and b. So I am just going to do. Suppose if I multiply with this one, I get 5a and plus here first tuple, that is 3b is equal to, that will give you here first tuple 27. First tuple 27 and second tuple 6a plus 7b is equal to 46 is there. If you simplify these two things, you will get a value and b value. So just add that a value and b value, you will get 7. Okay, so that is a simple one. You just do just see what is asking and just approach the question. So how can we get the answer? Okay, so this is the simple trick. So you just follow this one. So this is important also, these type of simple things. So you just find the a and b values and add, you will definitely get the 7 as the answer. And so 94 question is, if alpha comma b are the two vectors of an inner product space such that the mod of alpha comma b and norm space of alpha and norm space of beta is linearly dependent. So this is also direct statement. So if you remembering some statements, so you should remember those type of statements, because in this exam he is asking some statements, and if it is calculation part you can do whatever method you know. But if he is asking direct statement, means you cannot do directly. Some questions we can do by taking the counter examples, but you should remember everything. And the 97th question is, in an inner product space R cube. So he provided one alpha value 2 comma 1 comma 1. So he is asking norm of that one. This is simple one. We know that in general, whenever alpha equal to a comma b comma c is there, so we need to find the norm of that one. It is very simple. So we can directly say that under root of a square plus b square plus c square. So if you do that under root of a square plus b square c square, you get that value. So in place of abc, he provided this one. I just do that one. So that is 4. 2 square means 4. I am doing directly, and 1 square is 1 and 1 square is 1. So we will get that under root of 6. So the second option is the correct one for this question. And 96th one, in an inner product space V of f, mod of alpha comma beta is less than or equal. This is also direct statement. I already told you, in mainly in inner product spaces he is asking the direct statements. So you just remember the when it is symmetric and when it is satisfying the inner product spaces. So you can directly pick the answer without solving anything. So you just try to remembering those conditions when it is satisfying the above conditions. So the 97 question is B is a vector space of dimension m and W is the subspace of V of dimension n. So then the dimension of quotient of V minus W. So this is very simple one. So he is asking the dimension of V divided by W. So whenever these type of question come, so this is the direct one. I already told you, whenever dimension of W1 plus W2 is there, I just remembering by using the probability formula. So this is also simple, dimension of V minus dimension of W. So by using that, he already given that. So dimension of V is M and dimension of W is N. So we can directly get that M minus N. So this is a direct statement. You don't need to worry about these type of questions. If you remembering these type of formulas or statements, whatever it is, you directly get the answer. So the third option is the correct one for these question. So he is asking the rank. So this is, I think this is the third question by using the rank. So you should careful whenever you should solve more questions for rank, because the he is asking many questions by using rank only. So you need to know from what way you have to approach for finding the rank. So in previous problems we solved by using one rank nullity theorem and another question by using the linear transformation method, but he is provided asking by using the matrix method for finding the rank. Okay, so you should know all the methods to how to find the rank. So in the time only you can do easily, even if we ask rank by using the matrix or linear transformation method or by using the rank nullity theorem. Okay, so you should know everything. So he provided that one matrix A equal to 2 0 minus 1, this matrix. So you need to find the rank of these matrix. So that is very simple. So if you do that row operations, so one he say that third option is the correct one, that is a rank 3. So we need to find the pivot elements. So that is, you need to know how to find the pivot elements. So I am just writing the first column as this. So I will get 2 0 minus 1 0. So the second row should be same as this, 0 1 0 5. So the third row is same, 1 3 6, but the fourth row if you multiply with 2 this r3 and negative subtract with r4, you just get it 0 minus 0 minus 0. You can see that clearly there is a pivot element here and there is a pivot element here, there is a pivot element here. So the rank of this given matrix A is, you can say that 3 is the rank of these matrix, because we have only 3 pivot elements of these matrix. So we can say that rank of A is 3. So here we nothing we did, we just did that R4 minus R4 row operation. We just did that, we get 0 0 0 as a fourth row. Okay, so from that we can say that that is a rank of that matrix is a 3. Okay, so the 98th question option is 3 and 99 question is 2 comma 3 are the eigenvalues of 2 plus 2 matrix A. Then the sum of the eigenvalues of the matrix A, he is asking the sum, he is asking the sum of the inverse of the eigenvalues. You know that whenever A and in general A and B are the two eigenvalues of a matrix A, so the A inverse eigenvalues are directly say that 1 by A comma 1 by B are the eigenvalues of A inverse, because A inverse means we can literalize the 1 by A, right? So by using that we can say that 1 by A and 1 by E. In general we can do like this way, but he already provided the eigenvalues 2 comma 3, 2 comma 3. By using that one we can say that 2 comma 3 are the eigenvalues, so that will give you the inverse. These are the A eigenvalues. By A inverse eigenvalues are we get that 1 by 2 comma 1 by 3. So he is asking the sum of the eigenvalues of that one. So if I add these two eigenvalues of A inverse, I get that 6 and 3 plus 2, so that will give you 5 divided by 6. So this is the sum of the eigenvalues of A universe. So the third option is correct one, so the other options are wrong for this question. So the 100 question is, so he is asking the unit vector of orthogonal to. So I already told you, whenever orthogonal will come, so suppose the vector v1 is orthogonal to v2, then if you do the dot product with that, so it is simply goes to 0, then only we can say that that is a orthogonal unit vector orthogonal to 4 comma 2. So he is asking like that. If you do that process here, if it is goes to 0, then we can say that that is the orthogonal vector of a this tuple. So the second, the he is saying that first option is the correct one. You just verify by using that one, you can get the answer. So if you really enjoy this video, then try to like the video. So thank you.